In the silent darkness of space, a lonely star drifts through the galaxy, burning peacefully for millions of years. But somewhere ahead, hidden in the void, lies one of the most terrifying objects in the universe, a black hole. From far away, space looks completely normal, giving the star no warning of the danger ahead. As it slowly moves closer, the black hole's gravity begins to take control. The side of the star facing the black hole feels a much stronger pull than the side facing away, creating powerful tidal forces that begin stretching the star. At first the change is subtle, but within moments the star starts to deform, its once perfect spherical shape turning into a long glowing stream of plasma. Scientists call this horrifying process spaghettification, where gravity stretches matter into thin strands like cosmic spaghetti. As the star is torn apart, enormous streams of superheated gas spiral around the black hole, forming a blazing ring known as an accretion disk. Inside this disk, gas crashes together at incredible speeds, heating to millions of degrees and releasing powerful radiation across the universe. For a short time, the destruction becomes one of the brightest events astronomers can observe, known as a tidal disruption event. But the star's fate is already sealed. The shredded remains continue spiraling inward toward the most dangerous boundary in the cosmos, the event horizon. Once anything crosses this invisible line, escape becomes impossible. One by one, the final fragments of the star disappear into the darkness, leaving the black hole silent once again, drifting through the galaxy and waiting patiently for the next unfortunate star that wanders too close. But the destruction around the black hole does not end when the star is torn apart. As the shredded gas continues spiraling inward, the glowing accretion disk becomes more violent and unstable. Gas from the destroyed star crashes together at enormous speeds, creating intense friction that pushes temperatures to millions of degrees. The disk begins shining with powerful X-rays and radiation that can travel across billions of light years. Magnetic forces twist and snap inside the disk, building enormous amounts of energy. Suddenly, two massive jets of high-energy particles explode outward from the poles of the black hole, blasting deep into space like cosmic lasers. These jets can stretch for thousands of light years, carving through the surrounding galaxy. Meanwhile, the rest of the star's remains continue their final journey inward. Gravity grows stronger with every second, dragging the glowing matter closer and closer to the ultimate boundary known as the event horizon. From a distance, the swirling gas looks like a fiery whirlpool slowly disappearing into darkness. Time itself appears to slow down near this boundary due to extreme gravity, making the falling matter seem frozen at the edge. But in reality, the star's remains are still falling inward, crossing the point of no return forever. Once inside, nothing escapes. Not light, not matter, and not even information. The violent light show eventually fades, the radiation disappears, and the region of space becomes quiet again. All that remains is the invisible black hole, drifting silently through the galaxy, waiting patiently for the next star that wanders too close.